Chapter 1: A Tank for a New Kind of War. In the summer of 1940, American military observers watched with growing alarm as German panzers swept through France in 6 weeks. The fall of France exposed a brutal reality. The United States Army possessed fewer than 400 tanks, most of them obsolete light models barely suitable for reconnaissance. As Europe burned and Britain stood alone, American military planners understood they were witnessing a revolution in warfare, and they were catastrophically unprepared for it. The US Army had spent the interwar years developing the M2 medium tank, a design that emphasized speed over armor. By 1940, it was already obsolete. The M2 carried a 37mm main gun in a sponson mount, a configuration better suited to 1918 than to modern mechanized warfare. German tanks in Poland and France had demonstrated the superiority of turret-mounted guns with traverse capabilities, allowing crews to engage targets without exposing the entire vehicle. American designers needed to start over, and they needed to do it immediately. In August 1940, the Ordnance Department authorized development of the M3 medium tank as an interim solution. The M3 retained the sponson-mounted 75mm gun but added a turret with a 37mm weapon. It was ungainly, standing over 10 feet tall with a riveted hull that created deadly spalling when struck. But it could be produced quickly using existing manufacturing techniques, and in 1941 quickly mattered more than perfect. Even as the first M3s rolled off assembly lines, designers at the Aberdeen Proving Ground in Maryland were already working on its replacement. The specifications seemed straightforward. Mount a 75mm gun in a fully traversing turret, keep the armor thickness comparable to the M3 but lower the profile, maintain the same reliable powertrain, and above all design it for mass production. The result was the T6 prototype, which would become the M4 medium tank, the Sherman. The design philosophy behind the Sherman reflected a distinctly American approach to armored warfare. German tanks like the Panzer IV emphasized thick armor and powerful guns, accepting complexity and production challenges as necessary costs. The Sherman's designers made different choices. They selected a Wright radial aircraft engine for the initial production model, a proven, reliable power plant that American industry could produce in vast quantities. They designed the hull with large hatches for easy maintenance and escape. They used welded or cast construction methods suited to American heavy industry. Every decision prioritized reliability, repairability, and manufacturability over raw combat performance. The Sherman weighed approximately 30 tons in its initial configuration, with frontal armor between 50 and 75mm, depending on the variant. The 75mm M3 gun could penetrate most German armor at typical combat ranges in 1942, and its high explosive capability made it effective against infantry and fortifications. The suspension used a vertical volute spring system, simple, robust, and easy to maintain in field conditions. Maximum speed approached 30 miles per hour on roads, with reasonable cross-country mobility. The design wasn't revolutionary, it was sensible, pragmatic, and scalable. Production began in February 1942 at the Lima Locomotive Works in Ohio. By the end of that year, 11 factories across the United States were building Shermans or Sherman components. The tank that would define American armored operations in World War II had entered service not as the best tank on any battlefield, but as the tank America could build in the numbers modern war demanded. Chapter 2: Into Combat. The M4, Sherman first entered combat in October 1942 during Operation Lightfoot, the opening phase of the Second Battle of El Alamein. The British 8th Army had received 300 Shermans through the Lend-Lease program, enough to equip 3 armoured divisions. British tankers, veterans of 2 years of desert warfare, approached the American medium tank with cautious optimism. They had fought in Crusaders and Matildas, tanks that broke down constantly and whose armour and armament had proven inadequate against German opposition. The Sherman represented something different. Lieutenant Colonel Henry Foote of the Royal Tank Regiment recorded his first impressions after receiving his squadron's Shermans in September 1942. "The vehicle is roomier than our previous mounts," he wrote. "The turret traverse is powered, a revelation after hand-cranking a Crusader turret. The 75mm gun has both armor-piercing and high-explosive capability, giving us genuine versatility. Most importantly, the engine starts reliably, even in desert conditions. At El Alamein, Shermans proved their worth in sustained combat operations. British armour formations advanced through German minefields and defensive positions, engaging Panzer III and Panzer IV tanks at ranges between 500 and 1500 metres. The Sherman's 75mm gun could penetrate the frontal armour of a Panzer III at 1000 metres and could defeat the Panzer IV's 50mm frontal plate at similar ranges when using armour-piercing ammunition. German guns, particularly the long-barrelled 75mm K40 on late-model Panzer IVs, could also penetrate Sherman armour at these distances, creating an environment where tactical skill and situational awareness determined survival. American crews received their first combat experience 3 weeks later during Operation Torch, the Allied invasion of French North Africa. The 1st Armoured Division landed in Algeria with the 3 Lee tanks and the new M4 Shermans. Initial engagements occurred against Vichy French forces equipped with obsolete tanks and anti-tank guns. These battles provided valuable training, but revealed little about how the Sherman would perform against experienced German opponents. That test came in February 1943 at Kasserine Pass in Tunisia. German forces under Generaloberst Jürgen von Arnim launched a counter-offensive designed to disrupt Allied preparations for the final push toward Tunis. The attack fell primarily on inexperienced American units, including elements of the 1st Armoured Division. Combat reports from Kasserine reveal both the Sherman's capabilities and the consequences of tactical inexperience. Major Frank Walsh, commanding a company of M4s from the 1st Armoured Regiment, described the engagement. "We moved into position on a ridgeline as ordered, hull down with good fields of fire. German tanks appeared at approximately 1200 metres, Panzer IVs with the long gun. We engaged, scoring hits, but our armour-piercing rounds seemed to have limited effect at that range. Their return fire was devastatingly accurate. We lost 4 tanks in the first minutes. The problem wasn't the tanks. It was that we were silhouetted against the sky while they attacked from lower ground with the sun behind them. Textbook German tactics against our textbook American mistakes." The Kasserine Pass battles cost the 1st Armoured Division more than 50 tanks, but the losses taught critical lessons. American commanders learned that the Sherman required combined arms support, infantry to secure flanks, artillery to suppress anti-tank weapons, and reconnaissance to prevent ambushes. They learned that tactical positioning mattered more than armour thickness. They learned that crew training and leadership determined outcomes as much as vehicle characteristics. As Allied forces compressed German and Italian defenders into northern Tunisia through March and April 1943, Sherman crews accumulated combat experience. They discovered their tanks' mechanical reliability under sustained operations. While German tanks often required extensive maintenance after road marches, Shermans ran for days with minimal service. The powertrain proved robust, the tracks durable, and the suspension forgiving on rough terrain. When Shermans did break down or suffer battle damage, repair crews found them relatively easy to fix. The engine could be removed and replaced in field conditions. Track repairs required simple tools and minimal specialised knowledge. By May 1943, when Axis forces in North Africa surrendered, American and British tankers had developed a realistic assessment of their primary fighting vehicle. The Sherman wasn't invulnerable, no tank was. Its armour could be penetrated by German 50mm, 75mm and 88mm guns at typical combat ranges. Its own 75mm gun performed adequately against current German armour, but required favourable engagement conditions. What the Sherman offered was reliability, maintainability, and availability in numbers that allowed sustained operations. In North Africa, those qualities had proven sufficient to win. Chapter 3: The German Response. The Wehrmacht's armoured forces underwent a dramatic transformation between 1942 and 1943, driven by combat experience on the Eastern Front and growing concern about Allied material superiority. In July 1943, 2 new German tanks entered mass production, the Panzerkampfwagen V Panther and the Panzerkampfwagen 6 Tiger IV. These vehicles represented a fundamental shift in German tank philosophy toward heavy armour and high-velocity guns, and their appearance on Western Front battlefields would redefine armoured combat for Allied forces. The Tiger IV weighed 56 tons and mounted the legendary 88mm K36 gun, capable of penetrating Sherman armour at ranges exceeding 2,000 metres. Its frontal armour measured 100mm thick, proof against the Sherman's 75mm gun at any practical combat range. The Panther, slightly lighter at 45 tons, mounted a high-velocity 75mm gun with penetration characteristics comparable to the Tiger's 88mm. Its sloped frontal armour, 80mm thick at 55 degrees, created effective protection equivalent to 140mm of vertical armour. Both tanks represented engineering achievements of remarkable sophistication, and therein lay their weakness. Germany's armoured production capacity in 1943 totalled approximately 6,000 tanks across all types. The Reich devoted enormous resources to building complex, powerful tanks in limited numbers while facing enemies who could produce armoured fighting vehicles by the tens of thousands. A single Tiger required 300,000 man-hours to construct. A Sherman required 10,000. Germany built approximately 1,300 Tigers during the entire war. The United States built more than 49,000 Shermans. American tankers first encountered Tigers in Tunisia during the final battles for Tunis in April and May 1943. Lieutenant Colonel Louis Berer, commanding a Sherman battalion from the 1st Armoured Division, recorded his unit's first Tiger engagement. We spotted what we believed was a Panzer. 4 at approximately 900 metres. 3 of our tanks engaged simultaneously. We observed hits, sparks on the target's hull, but no penetrations. The German tank, we later identified it as a Tiger, traversed its turret with what seemed like deliberate slowness and fired once. The round went through Lieutenant Morrison's Sherman like it was made of cardboard. The tank exploded. We immediately withdrew using smoke. The encounter established a pattern that would repeat throughout 1943 and 1944. When Sherman crews identified a Tiger or Panther, standard doctrine called for immediate flanking manoeuvres supported by artillery and tank destroyers mounting higher velocity guns. The M10 tank destroyer, armed with a 3-inch gun, could penetrate Tiger armour from the side or rear at ranges under 1,000 metres. The later M36, mounting a 90mm gun, could engage Tigers frontally under favourable conditions. But Sherman crews quickly learned that their 75mm gun required side or rear shots to defeat heavy German armour. Shots that required tactical skill, teamwork, and often substantial risk to achieve. Combat reports from Italy through late 1943 and early 1944 reveal growing concern among Allied commanders about the Sherman's armament. Major General Ernest Harman, commanding the 1st Armoured Division, wrote to Ordnance Department officials in January 1944, "The M4 remains a reliable and maintainable fighting vehicle. Our crews trust it mechanically. However, the 75mm gun is increasingly inadequate against improved German armour. We need better penetration capability, either through improved ammunition or a new gun." The Ordnance Department had recognised this problem in 1942 and developed the M1 76mm gun as a Sherman upgrade. The weapon offered significantly improved armour penetration using HVAP, high-velocity armour-piercing ammunition. However, the 76mm gun's high explosive performance was inferior to the 75mm, making it less effective in the tank's primary role of supporting infantry operations. Additionally, the larger gun required a new turret design and reduced the crew's already limited fighting space. These factors delayed widespread adoption until after the Normandy invasion. American tankers developed tactical solutions to the Sherman's armament limitations. Platoon leaders learned to coordinate fire, with multiple Shermans engaging a single heavy tank to achieve kills through repeated hits or by catching the enemy during manoeuvres when thinner side or rear armour was exposed. Combined arms doctrine emphasised using tank destroyers, artillery and infantry anti-tank weapons to engage German armour, while Shermans provided mobile fire support and exploited breakthroughs. Air power, particularly the P-47 Thunderbolt fighter bomber, became an essential component of anti-armour operations, with forward air controllers directing strikes against German tanks that Allied ground forces couldn't engage effectively. Sergeant James Rothschild of the 4th Armoured Division articulated the tanker's perspective in a letter home written in December 1943. "We know the Sherman isn't going to win a one-on-one duel with a Tiger. That's not what it's built for. Our job is to keep moving, support the infantry, exploit gaps in the German line, and stay alive long enough to make the other poor bastard die for his country." The Sherman lets us do that because when we get hit and survive, and many of us do, We can get the tank repaired and back into action, sometimes within hours. Can't say the same for Jerry when his fancy Tiger throws a transmission in the middle of France with no spare parts within 100 miles. This pragmatic assessment captured the Sherman's actual role in Allied operations. The tank wasn't designed to fight Tigers and Panthers in frontal duels. It was designed to be produced in overwhelming numbers, maintained in field conditions and operated by crews with months rather than years of training. In a war of attrition against an industrial power with limited resources and shrinking manpower, those characteristics mattered more than any individual tank's combat performance. Chapter 4: Engineering by the Thousands. The story of the Sherman's production is fundamentally the story of American industrial capacity mobilized for total war. Between February 1942 and July 1945, 11 primary manufacturers and thousands of component suppliers produced 49,234 M4 Sherman tanks in multiple variants. This achievement represented not merely mass production, but the transformation of an entire industrial base to military purposes while simultaneously maintaining civilian economic function. The Ford Motor Company's contribution exemplified this transformation. Ford's Rouge River plant in Dearborn, Michigan, had pioneered automotive assembly line techniques in the 1920s. In 1942, Ford converted portions of this massive facility to tank production, applying automotive manufacturing principles to armored vehicle construction. The company designed specialized tooling that allowed workers with minimal training to assemble complex tank components with precision and speed. By 1943, the Rouge River plant could produce a complete M4A3 Sherman, from raw materials to finished tank, in under 10 hours of actual production time. Chrysler Corporation built an entirely new facility for tank production, the Detroit Tank Arsenal in Warren, Michigan. Construction began in September 1940 on an empty 113-acre site. The facility became operational in April 1941 and produced its first tank, an M3 Lee, in May of that year. By January 1942, the Detroit Tank Arsenal had shifted to Sherman production, manufacturing the M4A4 variant powered by Chrysler's A57 multibank engine, a unique design that connected 5 6-cylinder automotive engines to a common crankshaft. The Arsenal ultimately produced 7,499 M404 Shermans, most of which went to British and Commonwealth forces through Lend-Lease. The Fisher Body Division of General Motors operated the Fisher Tank Arsenal in Grand Blanc, Michigan, a facility that employed more than 17,000 workers at peak production. Fisher specialized in the M4A2 variant, powered by General Motors' twin diesel engines. This version was preferred by Soviet forces receiving Lend-Lease tanks, as Soviet tank crews had extensive experience with diesel power plants. Fisher Tank Arsenal produced 11,283 M4A2 Shermans between April 1942 and May 1944, making it one of the largest single-variant production runs. The Pacific Car and Foundry Company in Renton, Washington, brought West Coast steel fabrication expertise to Sherman production. The Press Steel Car Company in Pennsylvania contributed its experience in railroad car construction. The American Locomotive Company, Baldwin Locomotive Works, and Lima Locomotive Works, all builders of steam locomotives, adapted their heavy metalworking capabilities to tank production. This geographic and industrial diversity created production redundancy that protected against local disruptions and allowed continuous improvement sharing across facilities. Sherman production evolved through multiple variants designated M4, M4A1, M4A2, M4A3, M4A4, and M4A6, each distinguished primarily by engine and hull construction differences. The M4 used a welded hull and Wright R975 radial engine. The M4A1 featured a cast hull for improved ballistic protection. The M4A2 employed General Motors diesel engines. The M4A3, which became the standard late war variant, used Ford's GAAV-8 engine, a powerful and reliable gasoline power plant specifically designed for tank applications. The M4A4 carried the Chrysler multibank engine. The M4A6, produced in limited numbers, used a Caterpillar diesel engine. This variant proliferation, often criticized as inefficient, actually provided critical flexibility. When shortages of radial engines threatened production in 1943, manufacturers simply shifted to diesel or automotive gasoline engines without stopping Sherman production. When cast hull capacity became constrained, welded hull production absorbed the difference. The American industrial system's redundancy and adaptability kept Shermans flowing to combat units, regardless of component shortages or facility disruptions. Beyond the vehicles themselves, American industry produced the Sherman's operational ecosystem: spare parts, ammunition, maintenance equipment, and training materials. The Ordnance Department established a logistics system that tracked every component of every tank by serial number, allowing precise management of maintenance schedules and parts distribution. Depot-level maintenance facilities in Britain, North Africa, and later France could rebuild battle-damaged Shermans to like-new condition in weeks. Forward maintenance companies performed field repairs that kept tanks operational between major overhauls. The ammunition production infrastructure deserves particular mention. A single Sherman carried approximately 90 75mm rounds in its initial configuration. Sustaining a tank division in combat required producing millions of rounds annually. American industry rose to this challenge, manufacturing not only standard high-explosive and armor-piercing ammunition, but also specialized rounds including white phosphorus for smoke screening, canister rounds for close-range anti-personnel work, and later, HVAP rounds for improved armor penetration. By mid-1944, the United States was producing more than 2,000 Shermans per month, while simultaneously manufacturing vast quantities of other armored vehicles, aircraft, ships, artillery, small arms, and ammunition. This production volume overwhelmed Axis manufacturing capacity. Germany's entire tank production in 1944 totaled approximately 19,000 vehicles across all types, approximately one-third of Sherman production alone. Soviet tank production exceeded 50,000 vehicles in 1944, but the T-34s and heavy tanks rolling from Soviet factories required constant Allied material support in the form of steel, aluminum, trucks, and machine tools, much of it supplied by American Lend-Lease. The Sherman represented industrial democracy made manifest, a weapon system designed not for individual excellence, but for systematic overwhelming force, produced by an economy that could sustain total war indefinitely against enemies whose resources and industrial bases were finite and shrinking. Every Sherman that reached the front represented not just 30 tons of steel and machinery, but the productive capacity to build another and another and another, until victory was mathematically inevitable. Chapter 5: Adaptations and Field Modifications. The Sherman's most significant advantage over its opponents wasn't armor thickness or gun power, it was adaptability. The tank's basic design accommodated hundreds of modifications, both factory-installed and field-improvised, that transformed it into specialized vehicles for specific missions. This flexibility kept the Sherman relevant throughout the war despite the emergence of heavier German tanks and changing tactical requirements. The British Army pioneered Sherman modifications, driven by combat experience in North Africa and Italy. British tankers appreciated the Sherman's reliability but recognized its armament limitations. In 1943, British ordnance officers developed the Sherman Firefly, mounting the powerful 17-pounder anti-tank gun in a modified M4A4 turret. The 17-pounder could penetrate Tiger frontal armor at 1,000 meters and Panther armor at 600 meters, giving Allied tank formations genuine heavy armor-killing capability. Creating the Firefly required extensive modification. The 17-pounder's recoil forces necessitated reinforcing the turret ring and modifying the turret interior. The gun's length, 14 feet including barrel and breech, created balance problems that required removing the hull machine gunner position to add counterweight. The radio operator's position was relocated to the turret, reducing the crew from 5 to 4. Despite these complications, British workshops converted 2,100 Shermans to Firefly configuration between January 1944 and May 1945. Firefly crews developed specific tactical roles within British tank troops. Standard doctrine assigned one Firefly to each troop of 4 tanks, with the other 3 carrying 75mm guns for general-purpose work. The Firefly engaged German heavy armor, while 75mm Shermans provided supporting fire and dealt with infantry, fortifications, and lighter vehicles. This mixed configuration proved effective throughout the Northwest Europe campaign. American forces initially rejected the Firefly conversion, preferring to upgun Shermans with the domestically produced 76mm gun. The M1 76mm offered improved armour penetration compared to the 75mm, though it remained inferior to the British 17-pounder. The first 76mm Shermans reached Normandy in July 1944 after the initial invasion. By the war's end, approximately 4,400 Shermans had been upgraded with 76mm guns. Specialised Sherman variants address specific operational requirements. The M4A3-2 jumbo assault tank, designed for attacking fortified positions, carried frontal armour up to 152mm thick, heavier than a Tiger I. Only 254 jumbos were produced, but they provided critical breakthrough capability during operations against German defensive lines. The tank's weight increased to 38 tons, reduced mobility, but in the assault role, armour protection mattered more than speed. The duplex drive, or DD Sherman, represented one of the war's most unusual tank modifications. British engineers developed a collapsible canvas flotation screen and propeller system that allowed the tank to swim from landing craft to shore. The flotation screen, when raised, created a boat-like hull around the tank. Twin propellers driven by the tank's engine provided propulsion, at approximately 5 miles per hour in calm water. On reaching the beach, the crew collapsed the screen and the Sherman operated as a conventional tank. DD Sherman spearheaded the amphibious assault on D-Day, June 6, 1944. The 741st and 743rd Tank Battalions launched their DD Shermans from landing craft between 3,000 and 5,000 yards offshore at Omaha Beach. Rough seas and strong currents proved disastrous. 27 of 32 DD Shermans from the 741st Tank Battalion sank in the heavy surf, drowning many crew members. The 743rd Battalion, launching closer to shore, successfully landed 21 of 24 tanks. At Utah Beach, conditions were calmer, and DD Shermans provided crucial fire support during the initial assault. At British and Canadian beaches, Gold, Juno and Sword, DD Shermans operated more successfully, helping Allied forces secure their objectives with fewer casualties than at Omaha. The Normandy bocage, the Norman countryside's dense hedgerows, which were earthen banks topped with thick vegetation, presented unexpected challenges for Allied armour. German defenders positioned machine guns, anti-tank weapons and Panzerfausts in the hedgerows, creating deadly ambush positions. Tanks attempting to climb over hedgerows exposed their thin belly armour to enemy fire. The tight confines and limited visibility negated Allied advantages in mobility and numbers. American Ingenuity produced a solution. Sergeant Curtis G. Culin of the 2nd Armoured Division designed a hedgerow cutting device, fabricated from German beach obstacles, steel beams called Czech hedgehogs, captured after the D-Day landings. Cullen's device, nicknamed the Rhino, consisted of steel tusks welded to a Sherman's front hull. The tusks penetrated the hedgerow bank, allowing the tank to punch through rather than climb over, keeping the hull horizontal and the armour facing the enemy. The device added minimal weight and could be fabricated in field workshops using readily available materials. By late June 1944, ordnance units were producing Rhino cutters by the hundreds. Within 2 weeks, 3 out of 5 Shermans in Normandy had been fitted with hedgerow cutters or similar devices. This rapid field modification significantly improved Allied mobility in the bocage, allowing armour to support infantry attacks without exposing vulnerable hull undersides. Other field modifications address specific threats and conditions. Tank crews welded additional armour plates, often cut from destroyed German vehicles, onto their Sherman's hulls and turrets. They added sandbags, concrete or spare track links to increase protection. These improvisations provided limited actual benefit, the additional weight-stressed suspensions and transmissions without significantly improving survivability, but they gave crews a psychological sense of control over their fate. The M4 Dozer Sherman mounted a hydraulically operated bulldozer blade for engineering tasks, clearing obstacles, preparing firing positions, and creating improvised fortifications. The T-34 Calliope mounted a 60-tube rocket launcher above the turret, transforming the Sherman into a mobile artillery platform capable of saturating enemy positions with 4.5-inch rockets. The M4 A3R3 Zippo replaced the main gun with a flame projector, creating a terrifying weapon for attacking fortified positions and bunkers. Perhaps the most significant modification was also the simplest: improved ammunition. The introduction of HVAP, high-velocity armor-piercing, rounds in late 1944 dramatically improved the 76mm Sherman's penetration capability. HVAP rounds used a tungsten core and achieved higher velocities than conventional armor-piercing ammunition, allowing 76mm Shermans to engage Panthers and Tigers with improved effectiveness. However, HVAP ammunition remained in short supply throughout the war due to tungsten scarcity, and units received only limited allocations for critical engagements. These adaptations, factory-produced and field-improvised, sophisticated and crude, demonstrated the Sherman's fundamental design philosophy: practicality over perfection, adaptability over optimization. While German engineers refined the Panther and Tiger into increasingly complex and specialized machines, Allied forces modified the Sherman for every conceivable task, creating a family of vehicles rather than a single design. This flexibility kept the M4 relevant from 1942 to 1945 across every theatre of war, from North African deserts to European mud to Pacific jungles. Chapter 6. The Tanker's War. Inside a Sherman tank, 5 men occupied a fighting space approximately 9 feet wide, 7 feet tall, and 19 feet long. The commander sat in the turret's right rear, with the gunner forward and below him. The loader occupied the turret's left side. The driver sat in the hull's left front with the assistant driver and bow machine gunner on the right. These 5 men lived and fought in constant proximity, their survival dependent on coordination measured in seconds and trust built through shared danger. The crew positions demanded distinct skills and temperaments. The tank commander bore ultimate responsibility for tactical decisions: where to move, when to fire, how to coordinate with other tanks and supporting units. He maintained situational awareness through vision ports and the cupola hatch, while directing the driver's movement and the gunner's fire. A competent tank commander balanced aggression with caution, knowing when to press an advantage and when survival demanded withdrawal. Staff Sergeant Clarence Smoyer of the 3rd Armoured Division described the commander's burden in his memoir. "You're making life and death decisions every minute you're in combat. Do you move to that hull-down position or stay here? Do you expose yourself to engage that target or wait for infantry support? Every choice affects not just your crew, but the infantry relying on you, the other tanks in your platoon." The weight of those decisions never gets lighter, even after months of combat. You just learn to make them faster. The gunner operated the main gun and coaxial machine gun, working in darkness broken only by the gun sight's faint illumination. In combat, he took firing commands from the commander: target description, estimated range, ammunition type. The gunner traversed the turret electrically using a hydraulic system or manually using the traverse wheel, elevated or depressed the gun using a hand wheel, adjusted for range using the gun sight's ranging reticle, and fired when the commander gave the order, or immediately upon positive identification if facing imminent threat. Achieving first-round hits required understanding ballistics, estimating range accurately, compensating for target movement, and accounting for wind, temperature, and ammunition variations. Experienced gunners developed intuitive feel for their weapons' characteristics, knowing that armor-piercing rounds travelled slightly faster than high-explosive, that the gun tended to shoot low in cold weather, that the first round after prolonged travel might land differently than subsequent shots due to barrel temperature changes. The loader's job was physically demanding and dangerous. He manhandled 75mm rounds weighing approximately 15 pounds each from storage racks to the gun breech, often while the tank manoeuvred violently across rough terrain. Loading procedure required opening the breech, inserting the round completely, closing the breech, and immediately announcing "up" to signal readiness to fire. An experienced loader could maintain a rate of fire approaching 12 to 15 rounds per minute under ideal conditions, though sustained combat rates averaged lower due to fatigue and the need to retrieve ammunition from various storage positions within the turret. Private First Class John McAuliffe, a loader with the 4th Armoured Division, recalled the physical toll. "After a day in combat, your arms and shoulders feel like somebody beat them with hammers. The turret's hot from fired rounds, the air's thick with propellant smoke even with the fume extractor, and you're lifting those shells over and over while the tank's bucking and jerking, and the commander's yelling for more ammunition types, and you're trying not to think about what happens if a round penetrates while you're holding a shell." The driver controlled the Sherman's movement using a steering wheel or laterals, brake levers that controlled the tracks independently, allowing the tank to turn by slowing one track while the other maintained speed. The driver's visibility was extremely limited. Small vision ports provided narrow fields of view forward and to the sides. In combat, drivers often operated with hatches closed, relying on the tank commander's directions. Driver, advance. Driver, left 30 degrees. Driver, reverse now. This required absolute trust in the commander and immediate response to commands, as hesitation could mean the difference between survival and a penetrating hit. Technical Sergeant William Downs of the 2nd Armoured Division described driving in combat. You can't see much of anything except the ground directly ahead and maybe 10 or 20 yards to either side. You're listening to the commander, feeling the tank's response, trying to maintain speed and direction, while going over terrain that might be anything from smooth road to ploughed field to bomb crater. And all the time you're aware that your position, right up front, means you're probably catching any mine or anti-tank round that hits us head on. The assistant driver operated the bow machine gun and served as relief driver. He also monitored engine temperatures and oil pressure, managed the radio in early Sherman models, and assisted with navigation. The position was often assigned to the newest or least experienced crew member, as it offered fewer opportunities to directly influence combat outcomes, but provided essential training in tank operations and crew coordination. Crew coordination during combat approached choreography. When engaging a target, the commander identified and described it. Gunner tank 11 o'clock 800 meters. The gunner traversed the turret and acquired the target through his sight. Identified. The loader prepared appropriate ammunition. A P-up. The commander gave the fire command, fire. The gunner fired. The loader immediately began loading the next round. The commander observed the strike, short, add 100. The gunner adjusted elevation, set. The loader finished loading, up. The commander, fire. This sequence repeated until the target was destroyed or the situation changed. Well-trained crews could complete this cycle in 10 to 15 seconds. Survival rates for Sherman crews were better than popular mythology suggests. A 1945 US Army study found that approximately 94% of Sherman crewmen who entered combat survived the war, a rate comparable to infantry and better than some other combat arms. However, the perception of vulnerability had basis in reality. When a Sherman was penetrated by armour-piercing rounds, the results were often catastrophic. The gasoline engine and ammunition storage created fire hazards. Crew escape hatches, while well-designed compared to some tanks, could still trap men during fires or when the tank overturned. The term Ronson, supposedly applied to Shermans because they lit first time, is apocryphal. The advertising slogan actually post-dated the war. However, Shermans did burn when penetrated, particularly early models with ammunition stored in sponsons along the hull sides. The introduction of wet ammunition storage in late 1943, where ammunition was jacketed in water glycol mixture, significantly reduced fire risk. Tanks with wet stowage suffered fires in only 10 to 15% of penetrations, compared to 60 to 80% in earlier models. Crew esprit de corps developed through shared experience and mutual dependence. Tank crews lived together, ate together, maintained their vehicle together, and faced death together. Many crews personalised their tanks with names, painted insignia, and small comforts, photographs, pin-up images, unit emblems, or religious symbols. These personalisations transformed the Sherman from a machine into a home, cramped, uncomfortable, dangerous, but theirs. Lieutenant Belton Cooper, a maintenance officer with the 3rd Armoured Division, observed crew relationships. You could see it in how they moved around the tank, how they spoke to each other. A good crew operated with minimal communication. They anticipated each other's actions. A new crew replacement, even if individually skilled, disrupted that rhythm until they integrated into the team. The best crews weren't necessarily the most skilled individually. They were the ones who thought and acted as a single unit. When a crew member was killed or wounded, replacing him created challenges beyond the tactical. The surviving crew members had lost not just a teammate, but a brother. They had to incorporate a stranger into their intimate unit, teach him their procedures and preferences, and learn to trust him with their lives, all while continuing combat operations. Many tank commanders requested that replacement crewmen join during lulls in combat when time existed for training and integration, but operational necessity often required immediate integration under fire. Letters and diaries from Sherman crewmen reveal a consistent pattern: fear, and boredom in roughly equal measure, moments of terror punctuating long periods of waiting, pride in their vehicle's reliability contrasting with anxiety about its vulnerability. They recognized the Sherman's limitations while appreciating its strengths. They understood they were part of an industrial and military system designed to overwhelm the enemy through numbers and logistics rather than individual superiority. And they fought, day after day, inside their steel boxes, because the mission demanded it and their crews depended on them. Chapter 7: Fire and Steel in Normandy. The Allied invasion of Normandy on June 6, 1944, represented the largest amphibious operation in military history and the beginning of the campaign that would ultimately destroy German forces in France. For Sherman crews, Normandy would prove to be the most challenging combat environment they had yet encountered. Terrain that negated mobility advantages, defenders who had spent months preparing positions, and German armour formations that included significant numbers of Panthers and Tigers. The first Shermans ashore at Normandy arrived with the initial assault waves, some swimming from landing craft as DD tanks, others landed directly on beaches by LSTs. Their immediate mission was providing fire support for infantry attacking German fortifications. The 70th, 741st, and 743rd Tank Battalions supported American forces at Utah and Omaha beaches. British and Canadian forces landed with Shermans from the 13th 18th Royal Hussars, the Sherwood Rangers Yeomanry, and other armoured regiments. At Omaha Beach, where American forces faced the most determined resistance, the loss of most DD tanks from the 741st Tank Battalion in the rough channel waters meant infantry assaulted heavily defended positions without the armoured support planners had anticipated. The surviving tanks and those landed directly provided critical fire support, engaging German bunkers and machine gun positions with their 75mm guns. Sergeant James Donaldson of Company B, 743rd Tank Battalion, described the beach. We came off the LST into absolute chaos. The beach was under heavy fire, obstacles everywhere, dead and wounded men in the water. We engaged the fortifications we could see, bunkers built into the bluffs, machine gun positions. Our high explosive rounds were effective against the emplacements, but the Germans had positioned their defences well. We had to get close, sometimes within 200 or 300 yards, to get direct fire angles. Once Allied forces secured the beaches and began pushing inland, Sherman battalions reorganised and advanced to support the breakout from the coastal lodgement. The bocage country of Normandy, small fields enclosed by thick earthen hedgerows topped with vegetation, proved nightmarish terrain for armoured operations. Roads were narrow, sunken lanes that channeled movement predictably. Fields were small, providing limited manoeuvre space. The hedgerows themselves were dense enough to block vehicle passage and tall enough to provide concealment for German defenders armed with Panzerfausts, portable anti-tank rockets effective at ranges under 100 metres. German defensive doctrine in the bocage exploited these conditions ruthlessly. Panzer Grenadier units positioned anti-tank weapons to cover the limited approach routes, often allowing American tanks to advance into killing zones before engaging. A single well-positioned German infantryman with a Panzerfaust could destroy a Sherman with a shot to the side or rear armour. German tanks, Panthers from the Panzerlehr Division and the 2nd Panzer Division, Tigers from Schwer Panzerabteilung 503, occupied hull-down positions with excellent fields of fire, waiting for Allied armour to expose itself. The tactical problem facing Sherman crews was fundamental. The bocage negated their advantages in numbers and mobility, while emphasising the German advantages in individual tank performance. In open terrain, 5 Shermans could manoeuvre around a Panther, forcing it to choose targets while exposing its flanks. In the bocage, 5 Shermans might only be able to approach on a single narrow lane, creating a shooting gallery for the defender. American tankers adapted through combined arms tactics and hard-won experience. Infantry advanced alongside tanks, clearing hedgerows and providing security against anti-tank teams. Combat engineers accompanied armoured formations identifying mines and obstacles. Artillery forward observers in command tanks called fire missions on suspected enemy positions before tanks advanced. Fighter bombers provided air cover and attacked German armour concentrations that ground forces reported. The Battle of Villers-Bocage on June 13, 1944, demonstrated both the lethality of German heavy tanks in favourable conditions and the ultimate limitations of individual tactical victories. SS Obersturmführer Mikkel Wittmann, commanding a Tiger from Schwere SS Panzerabteilung 101, encountered a British column from the 7th Armoured Division advancing through the town. In approximately 15 minutes, Wittmann's Tiger destroyed or disabled more than a dozen British tanks, including Shermans and Cromwells, plus numerous half-tracks and supply vehicles. The engagement became legendary in German armour circles as an example of superior equipment and crew skill achieving dramatic tactical success. However, the strategic outcome told a different story. British forces withdrew from Villers-Bocage but continued offensive operations elsewhere. Wittmann's Tiger, damaged in subsequent fighting, withdrew for repairs. The British lost vehicles but replaced them within days from the constant stream of equipment arriving through Normandy ports. Schwere SS Panzerabteilung 101 began the Normandy campaign with approximately 45 Tigers. By August, through combat losses and mechanical failures, the unit was combat ineffective. The British 7th Armoured Division continued operations throughout the campaign, constantly receiving replacement tanks, crews and supplies. The introduction of 76mm Shermans in July 1944 provided American forces with improved anti-armour capability. The 2nd and 3rd Armoured Divisions received the first 76mm tanks and deployed them specifically as heavy tank killers, maintaining 75mm Shermans for infantry support and general-purpose work. Crews initially found the 76mm guns reduced high explosive effectiveness problematic. The smaller bursting charge was noticeably less effective against fortifications and infantry positions than the 75mm. However, against German armour, the 76mm proved significantly more effective, particularly when using HVAP ammunition. Lieutenant Colonel Wilson Hawkins, commanding the 41st Armoured Infantry Regiment, 2nd Armoured Division, described combined arms operations in the Bocage. We learned that tanks alone couldn't operate effectively in that terrain. Every advance required infantry to clear the immediate hedgerows, engineers to check for mines, artillery to suppress known or suspected enemy positions, and air support on call for targets we couldn't reach with direct fire. The Sherman's reliability became crucial. We could maintain continuous pressure on the Germans because our tanks kept running. German armour might win individual engagements, but they couldn't sustain operations. Their Panthers would break down after road marches. Their Tigers needed constant maintenance. Our Shermans just kept going. Operation Cobra, launched on July 25, 1944, broke the Bocage stalemate through massive application of firepower, followed by rapid exploitation. More than 2,000 Allied bombers saturated a 5-mile-wide corridor with high explosive and fragmentation bombs. Artillery added to the bombardment. When American armoured divisions advanced through the devastated German positions, they encountered disorganised defenders and broken defensive lines. The 2nd and 3rd Armoured Divisions, equipped primarily with Shermans, exploited the breakthrough, advancing dozens of miles in days rather than the hundreds of yards typical of Bocage fighting. German attempts to counterattack the American breakthrough at Mortain in early August demonstrated both the Wehrmacht's declining capabilities and the Sherman's role in mobile defensive operations. The German counteroffensive, Operation Lüttich, employed the 2nd SS Panzer Division and elements of the 1st SS Panzer Division, including Panthers and Tigers. American forces, forewarned by ultra-intelligence intercepts, prepared defensive positions and called for air support. The 3rd Armoured Division's Shermans, supported by tank destroyers and fighter bombers, contained the German advance. After 6 days of fighting, the Germans withdrew, having suffered irreplaceable losses in men and armour without achieving operational objectives. The Falaise Pocket in mid-August trapped approximately 100,000 German troops and the remnants of multiple panzer divisions in a shrinking enclosure as Allied forces from the south and north converged. Sherman battalions participated in the encirclement and the destruction of German forces attempting to escape. The scenes inside the pocket shocked even veteran tankers, destroyed German vehicles, dead horses, abandoned equipment, and thousands of prisoners created landscapes of devastation that demonstrated industrial warfare's terrible efficiency. By late August 1944, German forces in Normandy had been destroyed as effective fighting formations. The Wehrmacht lost approximately 450,000 men killed, wounded or captured in the Normandy campaign, along with most of their tanks, vehicles and heavy equipment in France. Allied forces lost approximately 209,000 casualties, with tank losses that were heavy in absolute terms but sustainable through continuous replacement. The Sherman had proven adequate to the task not through individual superiority, but through numbers, reliability, and the operational system supporting it. Chapter 8. From France to the Rhine. The breakout from Normandy transformed the war in Western Europe from grinding attrition to mobile warfare that played to Allied strengths. Sherman battalions advanced across France in late August and September 1944, moving faster than planners had anticipated and faster than logistics systems could fully support. The pursuit demonstrated both the Sherman's mobility and the challenge of sustaining mechanized forces hundreds of miles from supply bases. The 4th Armoured Division, commanded by Major General John Wood, exemplified aggressive armoured operations during this period. The division's combat commands, self-contained battle groups of tanks, armoured infantry and supporting elements, advanced in multiple columns, bypassing German strongpoints and racing for strategic objectives. On August 31st, 1944, the 4th Armoured Division covered more than 60 miles in a single day, demonstrating that Sherman tanks could sustain high operational tempo when fuel and maintenance were available. However, logistics increasingly constrained operations. Allied supply lines stretched from Normandy beaches across France to forward units. The Red Ball Express, a truck convoy system that operated 24 hours daily, delivered fuel, ammunition, food, and spare parts to advancing units, but demand exceeded supply capacity. By early September, many armoured divisions operated on minimal fuel allocations, conducting limited attacks rather than sustained exploitation. The decision to prioritise Field Marshal Montgomery's Market Garden operation in the Netherlands diverted supplies from American forces in eastern France. Market Garden, an ambitious attempt to seize bridges across major Dutch rivers and advance into Germany, required massive logistical support for British and American airborne divisions and XXX Corps, the ground element spearheaded by British armour. The operation, launched on September 17, 1944, ultimately failed when British airborne forces at Arnhem could not hold their bridge long enough for ground forces to relieve them. For Sherman crews in 3X Corps, Market Garden demonstrated the limitations of even the best tanks on unsuitable terrain. The advance route, a single highway across low-lying polder land, provided no manoeuvre room. German defenders positioned anti-tank weapons covering the road and destroyed lead vehicles, creating roadblocks that halted entire columns. British tankers found themselves fighting not mobile battles, but grinding advances against prepared positions, the kind of fighting that negated their mobility advantages and exposed them to German defensive firepower. By October 1944, Allied advances had stalled across the front as German forces established defensive lines and Allied logistics struggled to support forward units. The Sherman's mechanical reliability became increasingly important during this period of sustained operations. While German panzer divisions repeatedly found themselves immobilized by mechanical failures and fuel shortages, Allied armoured divisions maintained operational readiness through continuous maintenance and parts supply. Staff Sergeant William Grimes, a maintenance sergeant with the 6th Armoured Division, described the maintenance effort. "We'd work through the night, getting tanks ready for the next day's operations. Engine changes, track repairs, suspension work, whatever was needed. The Sherman's design made our job possible. We could pull an engine in a few hours using a tank retriever and the right tools. German tanks required specialised equipment and trained technicians. Our system was designed so that guys with a few months of training could keep the tanks running. That made all the difference when you're operating hundreds of miles from major depots." The German Ardennes offensive in December 1944, the Battle of the Bulge, tested Allied armoured forces against the Wehrmacht's last major attack in the west. German forces achieved tactical surprise, attacking through the Ardennes forest with 24 divisions, including elite Panzer and Panzer Grenadier formations. The offensive aimed to split Allied armies, capture the vital supply port of Antwerp, and force a negotiated peace in the west. Sherman battalions fought desperate defensive actions during the initial German attacks. The 7th Armoured Division's stand at St. Vith, the 101st Airborne Division's defence of Bastogne supported by attached tank destroyer battalions, and numerous small unit actions by mixed tank infantry teams delayed German advances and disrupted their timetable. The terrain and winter conditions limited mobility for both sides, creating a battle of attrition that favoured Allied forces with superior logistics and air support once weather cleared. The German offensive employed approximately 600 tanks and assault guns, including significant numbers of Panthers and the new Tiger II, mounting an 88mm gun even more powerful than the Tiger I's weapon. These heavy tanks achieved local successes, destroying numerous Shermans in engagements where German armour caught American forces out of position or achieved surprise. However, fuel shortages increasingly immobilised German armour. Many Panthers and Tigers were abandoned by their crews when they ran out of fuel, perfectly functional but useless without gasoline. The American counteroffensive to reduce the Bulge demonstrated Allied operational flexibility. The Third Army, commanded by Lieutenant General George Patton, disengaged from offensive operations in the Saar, pivoted 90 degrees north, and attacked into the southern flank of the German salient in less than 72 hours. This manoeuvre required moving more than 130,000 men and their equipment, including several hundred Sherman tanks, over icy roads in winter conditions. The Sherman's reliability and the Army's logistics system made this remarkable movement possible. Lieutenant Colonel Creighton Abrams, commanding the 37th Tank Battalion, 4th Armoured Division, led the relief force that broke through to surrounded American forces at Bastogne on December 26, 1944. His battalion's Shermans advanced through German positions in a narrow corridor, fighting through multiple counterattacks to open a supply route to the besieged town. Abrams, who would later command all US forces in Vietnam and serve as Army Chief of Staff, demonstrated aggressive leadership and tactical skill that maximised the Sherman's capabilities in mobile operations. By late January 1945, Allied forces had eliminated the German salient and resumed offensive operations toward the Rhine River. The Bulge cost the Germans approximately 100,000 casualties and 600 to 700 irreplaceable tanks and assault guns. German panzer divisions that had begun the offensive at or near full strength were reduced to battalion-sized battle groups by February. The Wehrmacht's armoured reserve had been expended without achieving strategic objectives. Allied forces crossed the Rhine in March 1945 at multiple points, with Sherman battalions providing the armoured spearhead for exploitation into Germany's industrial heartland. The Ludendorff Bridge at Remagen, captured intact on March 7th, provided an immediate crossing site. American armoured divisions poured across and established an expanding bridgehead on the east bank. Engineer units constructed additional bridges to accommodate the massive flow of men and equipment. The final campaigns in Germany demonstrated the Sherman's sustained operational capability. Armoured divisions advanced hundreds of miles in April and early May, encountering decreasing German resistance as the Wehrmacht disintegrated. Sherman crews found German panzer formations increasingly immobilised by fuel shortages and mechanical failures. Abandoned Tigers, Panthers, and other armoured vehicles lined roads throughout western Germany, left behind by crews who had no fuel to move them and no parts to repair them. The 2nd Armoured Division reached the Elbe River by April 12, 1945, having advanced from the Rhine to within 50 miles of Berlin in less than 3 weeks. Political decisions halted the advance at the Elbe, as Allied leaders had agreed that Soviet forces would capture Berlin. Sherman battalions that had fought from Normandy to central Germany ceased offensive operations and began occupation duties. When Germany surrendered on May 8, 1945, Sherman tanks occupied positions from northern Germany to Austria. They had participated in every major operation in Western Europe, from D-Day through the final advances into Germany. The tanks that American, British, Canadian and other Allied tankers had driven into battle were largely different vehicles than those they had started with, rebuilt after battle damage, upgraded with improved armour or guns, modified with field expedients, but still fundamentally the same design that had entered production in February 1942. Chapter 9: Legacy of the M4. The Sherman service did not end with German surrender in May 1945. Japan's capitulation in August 1945 concluded World War II, but the Sherman continued in American service and was supplied to dozens of Allied nations through military assistance programs. The tank's operational life extended well into the Cold War era, with the last combat use by military forces occurring in the 1970s. The Korean War, beginning in June 1950, saw Shermans return to combat with American and Allied forces. The 8th Army in Korea initially possessed no tanks when North Korean forces invaded South Korea. The North Korean People's Army fielded approximately 200 T-34/85 tanks, a Soviet medium tank comparable in capability to late-war German designs. The sudden armoured threat prompted emergency deployments of M4A3E8 Shermans from occupation forces in Japan to Korea. The M4A3E8, nicknamed the Easy 8, represented the ultimate evolution of Sherman design. It mounted the 76mm gun with improved ammunition, carried thicker armour than early production models, featured improved wet ammunition storage, and employed a new horizontal volute spring suspension that provided better ride quality and stability. The Easy 8 could engage 34/85 tanks on roughly equal terms, though Korean terrain often prevented the mobile operations where the Sherman excelled. Sherman tanks participated in defensive actions that halted the North Korean advance, most notably at the Busan perimeter in August and September 1950. The subsequent Incheon landing and pursuit north toward the Chinese border saw Sherman battalions operating in mobile warfare similar to late-war European operations. Chinese intervention in November 1950 changed the war's character, but Sherman tanks continued serving throughout the conflict, providing fire support in mountainous terrain poorly suited to armoured operations. The last American Sherman units left Korea in 1957, replaced by the M48 Patton tank. Israel became perhaps the most significant post-war operator of Sherman tanks. The Israeli Defense Forces received their first Shermans in 1948 during the Arab-Israeli War, acquiring vehicles from surplus stocks and scrapyards worldwide. Israeli engineers extensively modified these tanks, initially to restore them to operational condition, then to improve combat capability. The most significant modification program produced the M50 and M51 Super Sherman, mounting French 75mm and 105mm guns respectively. These weapons provided penetration capability comparable to contemporary tanks while retaining the Sherman's reliable mechanical components. Israeli Shermans fought in every Arab-Israeli conflict through the Yom Kippur War in 1973. The modified Shermans proved effective against Soviet-supplied armour, including T-54 and T-55 tanks, demonstrating that continuous upgrades could extend a World War II-era design's combat relevance for 3 decades. The last Israeli Shermans left frontline service in the mid-1970s, though some continued in secondary roles for several additional years. Other nations operated Shermans long after American forces retired them. Britain maintained Sherman Fireflies into the 1950s. France used Shermans in Indochina and Algeria. Pakistan, India, and numerous Latin American nations received Shermans through military assistance programs and operated them into the 1960s and 1970s. Paraguay operated Shermans until 2018, making them possibly the last Sherman tanks in active military service anywhere in the world. The Sherman's influence on post-war American tank design was complex. The M26 Pershing heavy tank, which entered limited service in early 1945, represented a deliberate departure from Sherman philosophy, emphasizing armor protection and gun power over mobility and production efficiency. The M26's 90mm gun could engage German heavy tanks on more favorable terms than the Sherman's 75mm or 76mm weapons. However, the Pershing's complexity and weight created maintenance challenges similar to German heavy tanks. Post-war American tank development oscillated between heavy, powerful designs and lighter, more mobile vehicles. The M46, M47, and M48 series tanks emphasized firepower and protection. The M60, which entered service in 1960, continued this trend with a 105mm gun and heavy armor. Not until the M1 Abrams in the 1980s did American tank design achieve a true synthesis of protection, firepower, and mobility through advanced technologies including composite armor and gas turbine engines. However, Sherman philosophy, reliability, maintainability, and sustainable production influenced American armored vehicle development throughout the Cold War. The M113 armored personnel carrier, produced in greater numbers than any American armored vehicle except the Sherman itself, embodied similar design principles: simple, reliable, easily maintained, and adaptable to numerous roles. The Bradley fighting vehicle, Stryker armored vehicle family, and other modern American armored vehicles reflect the lesson the Sherman taught, that the best weapon system is one that works reliably, can be produced in necessary quantities, maintained in field conditions, and adapted to evolving requirements. Veterans' assessments of the Sherman varied based on their experiences. Those who fought in North Africa and early Italy generally praised the tank's mechanical reliability and appreciated its superiority to earlier American designs. Veterans of Normandy and the battles in Northern Europe expressed more mixed feelings, respecting the Sherman's dependability while acknowledging its limitations against German heavy armour. Almost universally, tankers recognised that the Sherman's greatest asset was that it kept running, and that destroyed Shermans were replaced, keeping units operational throughout sustained campaigns. Belton Cooper's memoir, Death Traps, published in 1998, sparked renewed debate about Sherman effectiveness. Cooper, a maintenance officer with the 3rd Armoured Division, witnessed hundreds of destroyed Shermans during his European service and concluded that the tank was inadequately protected and armed. His account resonated with popular perceptions of the Sherman as inferior to German tanks. However, historians and other veterans noted that maintenance officers saw disproportionate numbers of destroyed vehicles. Their job was to recover and repair them, creating a skewed perspective on overall casualty rates. Statistical analyses of Sherman performance paint a more nuanced picture. American and British forces lost approximately 10,000 to 11,000 Sherman tanks destroyed beyond repair during World War II from total production exceeding 49,000 vehicles. Crew casualty rates, while significant, were lower than infantry rates and comparable to other combat arms. The Sherman's mechanical reliability, the aspect crews consistently praised, receives less attention than combat performance, yet reliability determined whether tanks could participate in operations at all. The Sherman's true legacy lies not in individual technical characteristics, but in demonstrating that modern war is fundamentally industrial and logistical. Germany built superior individual tanks in the Tiger, Panther and King Tiger, but couldn't produce them in numbers sufficient to matter strategically. The Wehrmacht couldn't maintain them in field conditions across extended supply lines. German industry couldn't replace losses at rates necessary for sustained operations. The Sherman, by contrast, was specifically designed for mass production, long-distance transportation, field maintenance, and continuous replacement. This represents the democratization of military technology, the application of mass production techniques pioneered by Henry Ford to weapons of war. The Sherman wasn't handcrafted by skilled artisans. It was assembled by industrial workers, many of them women entering the workforce for the first time, using standardized parts and systematic processes. This approach to warfare, industrial, systematic, sustainable, defined American military power throughout the 20th century and continues to influence military thinking today. The Sherman tank that landed on Normandy beaches, fought through the Bocage, and advanced to the Elbe River wasn't the best tank of World War II by any individual metric. It was the tank that won the war in the West because it existed in overwhelming numbers, worked reliably under brutal conditions, could be maintained by minimally trained mechanics, and was replaced faster than combat could destroy it. That achievement, victory through industrial democracy rather than technical perfection, remains the Sherman's enduring legacy. Chapter 10. Reflections. The contrast between German and American approaches to tank design during World War II illuminates fundamentally different philosophies of warfare and industrial organisation. German engineers pursued technical excellence, creating tanks with thick armour, powerful guns and sophisticated engineering. The Panther featured a powerful engine, excellent optics and sloped armour protection. The Tiger mounted the legendary 88mm gun and near-impenetrable frontal armour. These were magnificent machines representing the peak of armoured vehicle design in their era. However, this pursuit of excellence came with devastating costs. The Panther's complex transmission failed frequently under combat conditions. The Tiger required specialised tools and trained technicians for maintenance. Both tanks consumed fuel at rates that German logistics couldn't sustain. Production of these vehicles demanded skilled labour, specialised materials, and manufacturing time that diverted resources from other military needs. Germany produced approximately 6,000 Panthers and 1,300 Tigers during the entire war. Impressive numbers for such complex machines, but insufficient to stop the Allied advance. American industry took a different path. The Sherman design prioritised characteristics that industrial production could deliver: simple, robust mechanical components, easy maintenance procedures, standardized parts enabling large-scale manufacturing. American engineers understood that a tank that couldn't be produced in quantity, couldn't reach the battlefield, or couldn't be kept running had zero combat value regardless of its technical specifications. The Sherman embodied this philosophy completely. This represented more than just engineering choices, it reflected different national characters and economic systems. German industry in the 1930s and 1940s retained characteristics of pre-industrial craftsmanship, with specialized firms producing complex products in limited quantities using skilled workers. The German economic system under National Socialism emphasized autarky, national self-sufficiency, which limited access to resources and industrial capacity. Germany's war economy operated under increasing constraints as Allied bombing disrupted production and Allied advances captured resource-rich territories. American industry, by contrast, had spent decades perfecting mass production. Ford's assembly lines, General Motors' systematic management, and Chrysler's production engineering had transformed manufacturing. The American economy's vast scale, larger than the combined economies of Germany, Italy, and Japan, provided resources, industrial capacity, and labor that the Axis powers couldn't match. America's geographic isolation from direct attack meant factories operated without the disruptions that plagued German industry. The numbers tell the story starkly. The United States produced approximately 88,000 tanks of all types during World War II, 49,000 of them Shermans. Germany produced approximately 25,000 tanks and assault guns total. The Soviet Union, receiving substantial Lend-Lease support from America, produced more than 55,000 tanks, primarily T-34s. Britain manufactured approximately 28,000 tanks, many of them Shermans produced under license or received through Lend-Lease. The Axis powers faced opponents who could outproduce them by factors of 5 to 1 or greater in armoured vehicles alone. This disparity existed across virtually every category of military equipment. For individual tank crews, these strategic realities provided cold comfort when facing a Tiger's 88mm gun across a Norman field or a Panther in a German town. Tactical engagements occurred between individual vehicles and crews, and in those engagements, German heavy tanks held significant advantages. Sherman crews understood this, adapted their tactics accordingly, and fought with the weapons their nation provided. The tank duel at Cologne on March 6, 1945, captured by combat cameramen, illustrates both German technical superiority and the ultimate futility of that superiority. A German Panther engaged American armour at close range in city streets, destroying several vehicles before Sergeant Clarence Smoyer's Pershing tank, supported by several Shermans, manoeuvred for a side shot that destroyed the Panther. The engagement was recorded on film and became famous footage of urban tank combat. It demonstrated that even late in the war, German tanks remained formidable opponents, requiring skill and coordination to defeat. However, the strategic context surrounding that engagement tells the deeper story. The Panther's crew fought in a German city that American forces were capturing. The Wehrmacht had been forced back into Germany itself. Allied forces had secured uncontested air superiority, logistical dominance, and overwhelming numerical advantages in men and equipment. That single Panther, regardless of its technical excellence, couldn't affect the war's outcome. The Shermans and Pershing that destroyed it were part of forces that would continue advancing regardless of individual tactical outcomes. This raises uncomfortable questions about military ethics and resource allocation. Could American and British leaders have provided their tankers with better vehicles? The Pershing heavy tank existed in prototype form by early 1944, but production priorities and logistical considerations delayed its introduction until February 1945, too late to significantly impact the war. The British Firefly conversion proved effective but was produced in limited numbers. The US 76mm gun provided improved anti-armor capability but wasn't prioritized for early production. Did these decisions represent reasonable calculations about production capacity and operational priorities, or did they unnecessarily expose tank crews to risks that better equipment could have mitigated? Historical evidence suggests that Allied leaders understood the Sherman's limitations and made conscious decisions to accept them. Upgunning the Sherman to 76mm required new turrets, modified hulls, and production line changes that would have temporarily reduced output. The Pershing's introduction would have diverted resources from Sherman production and created logistical complications supporting two different medium-heavy tank types. British Firefly production was limited by 17-pounder gun availability and the conversion work's labour intensity. Allied leaders concluded that maintaining Sherman production volume was more important than fielding technically superior but less numerous vehicles. Were these decisions correct? The war's outcome suggests they were strategically sound. Allied forces won decisively in Western Europe, destroying German military power and forcing unconditional surrender. Tank losses, while heavy in absolute numbers, were sustainable and didn't prevent operational success. Crew casualty rates, though significant, were comparable to other combat arms. From a purely military effectiveness standpoint, the Sherman achieved its purpose. However, individual experiences resist strategic abstractions. For the crew of a Sherman destroyed by a Panther, they couldn't effectively engage. For the tanker burned when a penetrating round ignited ammunition. For the families who received telegrams informing them their sons or husbands died in tanks that crews called Ronsons, the strategic calculation offers limited comfort. The tension between individual cost and collective necessity defines modern industrial warfare's moral complexity. The Sherman represents both the power and the price of industrial democracy applied to war. Democratic societies mobilize their entire economic and industrial capacity for military purposes, creating material advantages that authoritarian opponents couldn't match. But democratic societies also ask citizens to fight and die in equipment designed as much for production efficiency as combat effectiveness. This bargain, accept technical compromises in exchange for overwhelming numbers and logistical sustainability, characterized Allied strategy throughout World War II. The Sherman tank rolling through German towns in spring 1945 carried more than 5 crew members and 30 tons of armour and machinery. It carried the weight of American industrial capacity, the philosophy of mass production applied to warfare, the assumption that sustainable volume mattered more than individual excellence. It represented assembly lines in Detroit and Dearborn, workers in Warren and Grand Blanc, the Red Ball Express trucking supplies across France, mechanics working through nights to keep vehicles operational, and the industrial democracy that produced not the best weapons, but enough weapons to win. Veterans returning from Europe and the Pacific brought complex feelings about their Shermans. Many praised the tank's reliability, grateful they could trust their vehicle mechanically even when its armour and armament proved wanting. Others expressed frustration about fighting in equipment they viewed as inferior to German counterparts. Almost all recognized that the Sherman did its job, not perfectly, not without cost, but adequately for victory. The Sherman story is ultimately America's story in World War II, a nation that entered the conflict unprepared, mobilized its vast industrial capacity, accepted casualties and compromises necessary for victory, and ultimately prevailed through material superiority and logistical sustainability, rather than tactical brilliance or technical innovation. The tank wasn't romantic or glorious. It was practical, functional, and mass-produced, characteristics that won wars even if they didn't inspire legends. In museums and memorials today, preserved Shermans stand as monuments to that practical approach to warfare. They represent not individual heroism, though Sherman crews displayed enormous courage, but systematic application of industrial capacity to military problems. They symbolize the moment when warfare became fully industrialized, when victory depended less on warrior skill than on factory output, when conflicts were won in Detroit as much as Normandy. The Sherman tank didn't overwhelm the Reich through superiority in any individual characteristic. It overwhelmed through numbers, through logistics, through the American industrial system's ability to produce, transport, maintain, and replace machines faster than combat could destroy them. In that achievement lies both the Sherman's legacy and its lesson, that modern warfare is ultimately industrial, that tactical excellence cannot overcome strategic insufficiency, and that in total war between industrial powers, production capacity determines outcomes as surely as battlefield courage.